highly diverse, soil diverse area, what do you expect to get from it in the sense of how you must actually have some idea as to what is going to come out of it. You're as a scientist, you're hoping that the data will drive your conclusions, but obviously you have some assumptions that you're making, some hypotheses. What are you expecting?
Well, so one of the ideas behind this new project is to try to look at what are the most important factors in driving, first in trying to predict carbon storage, but then also looking at how it changes over time after agricultural land use. And so what we're interested in teasing apart is rainfall more important, is temperature more important, is soil fertility more important, is the type of former land use, so are pastures, somehow pastures end up depleting your soil resources less than cultivation, and so reforestation is going to be a lot faster, and the soil carbon pool won't change as much, and forests will accumulate more carbon faster. Or is it the duration of the former land use? So if you have 90% of the land was deforested, but it wasn't used super intensively, it wasn't industrialized agriculture, we might not have depleted nutrients that much, so that reforestation was really quick, right? And so we're kind of thinking of a matrix of all these different factors that we can tease apart. We've got diversity of soil types, diversity of climate. We also have maps of historical land use in Puerto Rico that we can say, I want to pick 30-year-old forests in 5 different soil types, across different climates that they're all 30 years, so they're the same age, but they come from different former land uses. Or I want to pick this chronosequence after sugarcane, after pasture, after coffee plantation in the same climate or in a different climate. So to try to tease apart some of these factors. And I think soil type is going to be really important, and then also the intensity of the former land use are going to be really important. But that's what this research project will hopefully help us tease apart. Yeah, good questions. Eve?
It's actually slightly similar, but I guess following up on that, if you want to speculate, when you're showing your ordination, and even the 80-year-old plots are not quite the same as the reference plots, which is interesting. And you said, well, maybe eventually they would get there. If you want to speculate, I was remembering hearing, like in the 90s, ecologists who were doing similar work in upstate New York, and where the sort of maximal deforestation was maybe 1900. So by then they had some 80-year-old plots were there, and they said they could barely tell them apart. Forest. I mean, like maybe the beech trees hadn't moved in, but otherwise they were having a hard time distinguishing them. And yet in this area, they're still different. But so if you're just going to speculate, do you think they would eventually get there, or do you think that some of the land uses are like never ever going to be the same?
My thought is that, so one of the differences with the northeastern study sites is just much higher diversity of species here. What's interesting is that the forest structure is indistinguishable. So if you look at basal area, except for the biomass in the 80-year-old forest being higher, but stem density, the forest looks like the reference forest. It's just that the species are different, so it doesn't look the same. But in terms of forest structure. But my guess is that in our particular sites where we were working, the land use intensity was very low, which is why I think we get no change in soil carbon and we get really fast recovery. And so, I don't know, my hypothesis is that probably eventually those forests might be indistinguishable in terms of species composition. But that's something that Ricardo is going to be doing his dissertation on, is looking at what are the factors influencing succession and influencing the species come in, and how might changes in physical, environmental factors, soil resources affect successional trajectories. But yeah, it could be that 150 years, 200 years, they will look different.
It's pretty interesting to see how little the soil helped. I think in your introduction question where you're showing, deforestation and then you have pasture and then there's a lot of less biomass, I'm thinking, where?
Yeah,
And,
yeah,
I mean, so a pasture is not like a prairie. So, the prairies here, they always talk about how deep the roots go and everything, but if they're converting a forest over to a pasture right now, clearly those plants' roots aren't going down as far as, say, a normal prairie would have.
yeah.
When?
Well, a lot of the pasture grasses that they end up using, especially in South America, and some of them in Puerto Rico actually are very deep-rooted, and so they are contributing carbon below ground. But I think that's very soil dependent because I didn't talk about this because I was already talking about a lot of stuff, but our work in St. Croix is actually seeing changes in soil carbon and changes in soil nitrogen with reforestation. And it's a very different soil type, and it's a very different climate. And so that's why I'm interested in kind of trying to tease apart those factors, because I think we are going to find different trajectories based on soil type. Yeah. Yeah.
I'm just interested about this prediction about the forest carbon, and you said the model included former land use, and what about the present? What you predict about the future of the land use is going to actually affect this model?
Yeah, absolutely.
Socially driven
Yeah,
dynamics are happening there industrially or individually.
yeah, absolutely. Yeah.
Different type of agriculture,
Mm-hmm.
using different crops than before, how that can affect this new model. I don't know.
Yeah, that's a really good point. And the model that we're thinking of, which is really at this point just a model in my head, more than a quantitative model, includes current land cover. And so we've done a lot of work focusing on current forests, but actually we're measuring croplands, pastures, other current land covers. And actually the original proposal that I submitted to do this work included some land use scenario modeling, and the reviewers didn't like it. So I took that out of the project. But it is something that I hope to incorporate in the future. And there actually are researchers at the Forest Service in Puerto Rico who have both climate change scenarios and land use change scenarios for Puerto Rico. So we could easily add our data to those models. And they're using those models to look at biodiversity, changes in species composition in response to these environmental factors. But we could easily add carbon, for sure. So yeah, really good point. Especially in a place that has a very dynamic land use change. I mean, it's continuing to change, right? We're actually, we had an increase in forest cover, and I think we're starting to do this in Puerto Rico because of urbanization or residential development, right? And so, really good point, yeah. Great, well, thank you. Okay, one more question, but then I know people have to go.
In Madagascar, we talked about natural reforestation, but there's also man-made forestation, chopping down trees. I'm just wondering why they always pick to plant pine trees instead of something more useful like fruit trees. Because pine trees, I know they grow them to cut them down again. So once they grow, they cut them, use them as lumber. But why don't they grow trees that could last and produce some sort of sustainable, is there any particular reason for that?
Yeah, foresters like their forestry species, and they're not agriculturalists. I think it's just a tradition, right? I mean, foresters will plant, there's a number of species that they'll plant all over the tropics, eucalyptus, pine, mahogany, which are valuable timber species, or they just know how to manage them. And they're not necessarily, they don't have the same goals that you're expressing in your question. But that is a very good point. Yeah. Great, thank you so much.
Thank you.